So, all we're working on today is we're going off of things that we learned yesterday. We're just going to combine them and make them more complex and more difficult. So, we're going to take all the laws that we learned yesterday, like our product law and our quotient laws, and we're going to combine them all into massive formulas. First one, let's just jump right into examples. You need to learn bed mass. Who remembers that? Bed mass? It's your order of operations.
Yes.
I learned another way to do it. Please excuse my dear Aunt Sally, I guess, another way to do it. Some people use that, but I use bed mass, typically. Pardon? That's a lot more difficult, actually. Bed mass is easier. So let's review it though real quick. What's the B stand for?
Brackets.
Brackets. So anything inside of brackets, you do first. What's the E stand for? Yeah. What's the D? Line. What's the M? Multiply. Yeah. And those things could be flipped, right? It could be the M before the D, or the D. Yeah, and then it doesn't sound as cool, right? A. Yeah. And then the S. You can flip those ones too, also doesn't sound as bad. Okay. Those are important. We have to follow those every single question or else it's not going to work. So what you do for this first question, when you have brackets multiplied like this, they have to apply to each other. So the coefficients you multiply together, and the x's you're going to multiply together. So you multiply the coefficients, what do you get?
Would it be 6x?
It'd be 4 times 2 is C, and the x fifth times x to the power 3, what would that be? X8. What law is that?
Wait, so you're adding.
Yes. So when you multiply two things together, you add the exponents, correct? B, it's the same thing. Now we're going to multiply more things. So the best way to do this so you don't confuse yourself, just multiply those together, make a new equation, and then multiply the next things together. So if we were just doing this first chunk, what would it be? 389. She's right. So the 3 isn't going to multiply with anything because the coefficient there is just 1. And 8 to the power 4 times 8 to the power 5 is 8 to the power 9. And then put those things in brackets. And then you still have this left over. 683. And then you just do it again. So you could have a whole bunch of these in a row, and you just keep doing them one at a time, so you don't lose yourself. So what's the final answer going to be? 18, 8 to the power 12. So we multiply our coefficients, and then we add our exponents. This one. We need to talk about simplifying coefficients. These bad boys. You need to simplify those. So when you have two coefficients that are divided by each other, you make them their lowest terms. What's the lowest term? 30 divided by 45. You don't change it to a decimal. 6 over 9?
Oh, no, wait, no.
That's a good start.
Then 2/3.
You keep bringing it down, right? So you find a common, something that multiplies into both of them. She used 5. So 30 divided by 5 would give you what? 6. And 45 divided by 5 gave her 9. But then she also knew that those things had something in common. It's 3. So 3 goes into 6, you're left with over 3. Every single question we do, you need to get it in the lowest terms. You give me that, it's wrong. You leave it like this, it's wrong. If you change it to a decimal, it's wrong. Lowest term.
Or on that one, you can go like the biggest number that goes into it, which is like
15. If you had identified 15 goes into them, yeah, Matthew's right. It just goes quickly into 2/3, right? Same idea. A lot of you on your graphing calculators, these ones, if you punch in, open it up, I'm going to show you a trick right now. If you go 30 divided by 45 right now, and it gives you 0.666667, go math, and number 1, the fraction button. Okay, math, frac, enter, enter, and it'll give you the lowest term fraction. Liam, you got a question? Pardon? No.
Front, inside last.
Okay. We still have to deal with b's. What do we do with our b's? B14 to b to the power of 10. And how do we simplify them, Michael?
Oh, okay, so I was right.
Yep. So what's the quotient law? Subtract what, Eric? 14 by 10. So if you have two things that are the same and they're dividing, you subtract the exponents. So I'm going to leave it as b14 over here, b10, and then we simplified it, so it's just b to the power of 4. And it goes on the top. You have nothing left here. Garbage, nothing. It's gone. You've dealt with it.
Does it like always go on the top, or is it one with the bigger?
Always goes onto the top, and then if it's negative, we'll deal with it. So if the bottom number had been 14, 10 minus 14 would have been minus 4, right? Always put on the top. So it would have been b to the power negative 4. And then we'll deal with those and learn how to flip them to the bottom. This last one, down here, b. Michael, got an idea? Maya doesn't. I thought you did have an idea. So you did x to the power of
X equal.
8y12.
Oh, I see.
So, the reason she did that, you can only deal with the same things, right? So your y's would go together and your x's would go together. You have to have the same base. So the two x's added together gave her x to the power of 8, because 5 plus 3 is 8. And the y's together gave her 12. With 8 plus 4 is 12. Next question. You see how these just keep getting bigger, right? Same thing for e. Simplify the coefficients. What do we get when we simplify the coefficients? 5 over 2. And put it over here. Then we have to simplify the e's. What do those become, Murphy?
They comes e over 4.
E to the power of 4, yeah. And fourth, simplify the f's. Michael said, oh, Murphy gives us, yeah.
F to the power of 10.
F to the power of 10. And the last one, we haven't done this long. Emma, got a question?
Do you always leave it as a proper fraction?
Yeah. So leave it as 5 over 2 rather than you want to take the 2 out, or the 1 whole 1 out. Yeah. No, leave it like that. So it wouldn't be 2 and 1/2. Leave it as 5 over 2. Yeah. Extractions are a pain. I don't like them. F. What law is that? Right. So you multiply the exponents in. So this exponent needs to go to here, but it also needs to go to there. The coefficient. When you do that, we'll do it here. Close. So it'd be 3 to the power of 3, and then x to the power of, what Michael said, 6. But it's 3 to the power of 3, not 3 times 3. What's 3 to the power of 3? 27. So your final answer is 27 x to the power of 6. Be careful not to multiply the actual numbers. You multiply the exponent in. The exponent on this coefficient is just 1. It's not there. Any questions on this? These are easy ones. They're going to keep getting harder. Okay. So here we have x's on the top and we have x's on the bottom. So my advice to you is going to be to always simplify everything on the top and simplify everything on the bottom. Cool. And then you can do the tops and the bottoms together. So if you simplify the top, what would you get? x8. So it's x to the power 3 times x to the power 5. You add them together. At the bottom, what would you get? x3. And now we've simplified the top, we've simplified the bottom, we can do the whole thing. x5. So x to the power 8 minus the 3. This one. What does bed mass tell us that we have to do first? Brackets. Brackets. So we do all our brackets. Nothing on the inside needs to be done inside the brackets, right? They're all just already multiplied together. So then what's the next step? This exponent right here? That one? Yeah. Because it's on the outside of the brackets. So it needs to come into the brackets first, right, Reese? Okay. So when you multiply the 2 in, what is it going to give us? 5 to the power of 2.
And we're going to also make AB12.
It'd be a to the power of 2 and b to the power of 12. So each one of these terms are individual terms. They're not connected. They're multiplied together, but the term isn't AB. The term is A, and the other term is B. Yeah, it is a bracket still. So, what do we have on the other side? We still have 4a squared b. We need to simplify that, so it's just 25. Five squared is 25. You can write that as your next step. I'll run out of space, so I'm not doing it.
So you multiply 25 by 4 to get 100, and then you multiply 85 by 85 2, so you just add this one to 4, and then b to the power 12 plus b is right.
Yeah, Murphy's on fire. He's got it. So what he's saying is you multiply the coefficients by each other, the a's by each other, the b's by each other. And then use our laws to add them all together. What's 25 times 4? 190. What are the a's? A4. Your parents paid for you. That's for the record, Joe. The government paid to see that happen. Your parents paid to see that happen. Your grandparents.
Oh my god, they're actually
Tell her to watch the video. She can listen to all of it. Reese, what's the question?
If you're multiplying B12 times B1, it would still be 12.
Right, but we're not multiplying, right? So when we have B12 times B to the power 1, the law is to add them together. That law, two things multiplied, is addition. When you have B to the power of 12 to the power of 1, that's multiplication. So it would be 12 times 1. And it would stay as B to the power of 12. Two things multiplied, half. Michael.
Why did you put
That's a good question. So we multiplied these B's by all of these B's. The B's were multiplied, which is why you add the exponent. So let's look at this. I'll show you. I'll show you why you add. So B to the power 12, what's that actually saying? saying b times b times b 12 times, right? Times b times b times b 12 times. What's the b to the power 1 saying?
1b.
So if we were to multiply all that by all that, we would have 13 b's. Correct? You're just adding it on to the end because you're multiplying it on. So it goes b, which makes that b13. That's why we add the exponents when we multiply. Josh? Yes, sir. Does that make sense? Why we add them? Alright. This one. When we say deal with the top first, deal with the bottom second. Alright, let's deal with the top. What do we have to do? The brackets. So what from the brackets do we deal with? This 2 needs to come into the brackets. The 16 out front is outside the brackets. You don't have to do anything to it. Because it's outside the brackets, it just stays there. What do we do with the x? Times by the other exponent. So what do you get, Matthew?
Get x, 6, and y.
And y?
Both are.
Yeah. So we multiply these exponents. On the bottom, what do we get? The 2 is now inside the bracket.
So it's 6 to the power of 3.
2 to the power of 3. Because this 2 is inside the bracket, so it needs to go there, it needs to go there. 2 to the power of 3 times x to the power of what? X to the power of what? 6. What's 2 to the power of 3? Erase this and put 8. Did you guys get the next step? A really messy 8. We're not done. What do we have to simplify? We have to subtract what, Aaron? Our x's. And what do we have to do with our coefficients? Stop. Divide them. So what do we get when we divide them? 2. And Aaron was right about our 6's. What do we do with that? So 6 minus 6 is, and anything to the power of 0 is 1. So just put 1. Don't put anything. Yeah, it's 1. You would write in a coefficient, right? You don't put anything in. So then you just have 10. When you have something to the power of 0, it's just 1. Do we write 1 in as our coefficient? Nah, it's a waste of space.
So the answer is just 2.
2y to the power of 10. Liam. What do you mean?
If you just take it out, you're eliminating that entire factor from the equation.
So you still want x to the power of 0 in it?
No, you don't put to the power of 0, you just put x.
If you put just x,
But it'll need x.
then that would be x to the power of 1. Which isn't true. Wait, hey! Didn't realize there's all of a sudden 35 other teachers again. So,
That's what I'm saying.
I'll answer it. That's why this question's in here, because it's supposed to be confusing. I'll do nothing. We have x 6 divided by x 6. Hey! Right, because 6 minus 6 is 0. So then that is equal to x to the power of 0.
Okay.
Correct? X to the power of 0 is equal to 1. Because anything to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So now x's are gone out of your equation. They don't exist anymore. They've canceled each other out. Yeah, mind blown. It is confusing. That's why each one of these questions are in here for a reason. For different circumstances. Any more questions about that one? Jay, what do you deal with first? Awesome. No, you.
The 4.
The 4 on the outside. So where are we putting it?
And all the other stuff.
All the other stuff. And by all the other stuff, we mean like literally everything.
Yeah.
Yeah. So it's going to apply everything.
What about the, is that like another
But-
include, or is that like a type? Is that that's an
That's a multiplication sign. The x's will be in italics.
Yeah.
Italicized? What do we have to do with that 4 and that 3 before we can bring them in? They're inside the bracket, so we have to deal with them first.
Oh.
Joe's right. We need to multiply the 4 and the 3 first.
Really?
So, on the top we'll have what, Joe?
I don't know.
12.
12
Y3,
y3.
X, and the brackets are still there.
Does it matter if it's the first or
No, you can put the X first, you can put the Y first. Multiplication, the order doesn't matter. On the bottom we still have X to the power 5, and that's all still to the power 4.
But wouldn't you apply the 4 to everything with the brackets?
Right, but we had to deal with, Matthew, we had to deal with this 4 and this 3 first, because they were inside the brackets. Our bed maps, right? Things inside the bracket first. So you do have to do it this way first? Yes, because I'm about to show you why. What else can we simplify in there first?
Oh wait, I was just gonna say, don't you multiply the 4?
Not yet. What else can we simplify inside the brackets?
12 and 6.
The 12 and the 6, and what else? And the x's. So, deal with those. The 12 and the 6 gives you
6. Oh,
2. The 12 divided by 6 was 2. They're y's, you're going to leave them alone, right? Y to the power of 3. Now what do your 6's going to become? 1.
Yes, not.
Because x to the power 6 minus x to the power 5. Just 1 left. 6 minus 5.
And the 4 is
The 4 is still here. So we have to deal with all of that before we can bring the 4 in, and it would change your answer, because if we brought that 4 in, and the 4 in there, it's going to make a bigger difference than just 1. Yeah.
If you did it
No,
wrong,
it'll give you the same. Should call it the same.
if you did it wrong, wouldn't it be like 48 y 12 to x 24 divided by 6 to the power 4 x 4?
I have no idea. That was a lot of numbers. I'm not sure. Yeah, we'll see the final answer to the finish. Got a question? Oh, yeah.
Why did you get 12 like
The 12 came from 4 times 3. Your coefficient's on the top, right?
okay.
You have to deal with the things on the top first. Now what's your final answer? Bring this 4 in.
2 to the power 4 y 12 and x 4. Wouldn't it be x 5?
So the 4 is outside, so it's all this to the power of. So you multiply your exponents. There wouldn't be an x, so what's 4 times 1?
4, but the way you explain it would be 12 b.
But that's when we're multiplying these together. We're not multiplying x's by more x's. We're something to the power of something. This is x to the power 1 to the power of 4.
Yes.
Right. Any question about that? You're going to see more complicated versions of this on quizzes and assignments.
Do you solve it to the power of 4?
Absolutely. What do you get? 8? 16. Yeah. Your final answer, you would solve that. It'd be 16 y to the power 12, x to the power 4.
Negative 16.
And you get the same thing. Yeah. So you're goodbye.
She just won 4 waves.
Integral exponents. We're going to keep going. Yes. Yes. Ella, what's an integral? Dawson, help her out. What's an integral?
Oh, it's like the
It means integrals are something from integers. It means integers. It's technical. Integrals are something you won't deal with.
I won't deal with
Integer is what it's supposed to say.
it.
Yeah.
Not
Integer exponents. What are integers? Integrals are definitely a thing. They're definitely not something you're going to see in grade 10.
well, I see the
What are integers? Negative numbers. So,
negative.
negative 3, negative 2, negative 1, 0, 1, 2, right? So, this is when we're going to start dealing with our negatives. Once using your calculator, you'll get 9. No, you won't. 27. Then you'll get 9. 3, 1.
You got 2 R's.
very tricky.
What's 3 to the power negative 1?
0.33.
Punch in your calculator. What's 3 to the power negative 1?
1 over 3, because when you have a negative integer or a non-negative exponent, it doesn't make it negative, it just makes it
Yeah, so
1
that
over 3 is the same.
0.3333. So Matthew's figured it out for us. Michael's also figured it out for us. It's okay, big guy. What is 3 to the power negative 1 when you put your calculator? What's the repeated number, Dawson? What's 3 to the power negative 2 in your calculator? Matthew said that this, and others also said, is the same as what? 1 over 3. What is that the same as? 1 over 9. Same as 1 over 3 squared. So when you have a negative exponent, it means you can take the base that it's attached to and put it underneath, so it becomes from numerator to the denominator.
So you can take off the negative.
So imagine, because 3 to the power negative 1 is just over 1. We just don't write divided by 1 because that would be a waste of time, right? You just take this and it goes right there. So negatives take the entire power and put it underneath the division sign. From denominator to numerator or numerator to denominator. It goes both ways. So if I had 3 to the power of 3, that's also the same as 1 to the power of 3 to the power of minus 3. Because those are just flipped to the top and it becomes a positive number. We'll do some examples so it makes more sense.
No examples.
Oh, sure.
My brain is
Here's your law. This will make it simple. Anytime you're confused about negative exponents, this is the page that'll save your life. Some quick examples. Now we're going to do negative laws, but we're also going to do our regular laws. So what do we do? Michael, we multiply these two powers, what do we do? add the exponents, and they're negative. So negative 4 plus negative 3 is... The rule for this unit will be no negative exponents. If you give a negative exponent, it's wrong. So what do we convert this to? 1 over b to the power of 7. That makes it positive. When you take a power and you flip on what side it's on, from the top or to the bottom, it changes the exponent from positive to negative. Or negative to positive. But you're never going to want a negative. Next question. What's our laws tell us to do?
Subtract it.
It's division, right? So we're subtracting our exponents. So what do we get? X to the power of negative 5. And what do we do with our coefficients? What are they? Divide them. And what's 6 divided by 2? We don't want negative exponents. So what's this equal to?
1 over 3x.
Close. Just that power is to a negative exponent. What's 3 to the power of? 3 is to the power of 1. You just don't see it. It's a positive exponent, so you don't move it. So the 3 is up top, and the x goes down. Anything with a positive exponent, you don't move. That 3 is technically to the positive exponent of 1. Just the x moves. This one. Deal with our coefficients. What does that give us? 2. B divided by 4 is 2. Here's the example we talked about earlier. What's b to the power of negative 5? Oh, it's an a, isn't it? So we have a to the power of negative 5 and b to the power of negative 3. Can we do anything with them? No, because the bases are different. But they're negative exponents, and we don't like negative exponents, so what do we do with them? This part needs to switch down low, and that part needs to switch up top. Because we don't leave negative exponents as our final answer. So it would be 2 e to the power of 3 divided by 8 to the power of 5. Any questions on that one? Yep. So we take all of our powers which have negative exponents. 8 to the power of negative 5 is a power with negative exponents. So that right there needs to switch to a positive exponent, correct? To switch it to a positive exponent means you need to put it on the other side, which means we need to move it to the bottom. And that's how it got there. Another power to a negative exponent is b to the power of negative 3. The other way to make it a positive exponent is to put it to the other side, which means we move it to the top. By switching what side it's on, you switch the exponent from being positive or negative. Example 2 down here. Simplify with positive exponents. And then do the questions above, because I don't have a space down below. That's c over d, correct? When we bring in the exponent, what do? Yep, so we go negative 3, correct? Awesome, yeah, good. They're both to the power of negative exponents, so you flip them. So it becomes d to the power of 3 divided by c to the power of 3. Yeah? Make sense? No.
If that was on our test, then we have to show like this part.
Bringing the exponent in.
That the right.
Yeah. Yeah. question. The question is C divided by D.
Oh, okay, never mind, you did it up there, so it's
Oh yeah, no, I'm doing it above, sorry. Now I'm going to show you a trick that's going to make your life easy. You have anything like this. So it can also look like this. You can have X, Y, Z over A, B, C. The power of negative 5. Anytime you have a bunch of stuff divided by a bunch of stuff to the power of a negative, you can get rid of the negative exponent by just flipping everything in the brackets. So you're applying the flip before you're applying the -1 in before you're actually dealing with any of your problems. So you can get rid of that and it becomes C over D. All the power. Multiply the 3 in. It might save, some of you might find that easier and save you work in the future. Others might like to do the whole thing at once. It's your choice, you'll get the same answer. Because when that 3 comes in, you're going to have C to the power 3 divided by D to the power 3. It's going to be the same, right? Oh, I didn't flip it. I didn't flip it. So you flipped everything inside the brackets. That got rid of your negative sign. So for this one, it would now be ABC divided by X, Y, Z. All the power 5. Some of you might find that easier. Some of you might like to do it the first way that I do it. I like to do it the first way. So that's how you'll see me do it now. E. Just apply the -3 in. X to the -3, divided by 4 to the -3. What do we do? Flip them both. So it's 4 to the power 3 over X to the power 3. And 4 to the power 3 is equal to 16. The next one. We multiply the -3 in. What's it do to the P to the power 2? Negative what? -6. You multiply the exponent in, right? So it's 6 times 2, or 3 times 2. And then negative. R to the -12. Final answer is just those two things flipped. Right. So it's R to the power 12 divided by P to the power 6. Yes, Michael. Right. So when you do negative times a negative, what does it do, Michael? Right, so he's brought the -4 in just like we did before. -4 times -2 is just a to the positive 8, and then b to the positive 20. Right, if it's positive, just leave it as positive. You have no issues to deal with. Okay, that does it for today. That was a long one.